In the previous video, we had learnt how a light ray gets refracted when it passes through a prism. Let's recall that the emergent ray here is not parallel to the incident ray because of the unparalleled faces of the triangular prism. We all might have seen the spectacular rainbow after a rain, or the colorful soap bubble, or even the colorful light when oil gets spilled on watery road. All this is because of dispersion of light. So in this video, let's learn about dispersion. In the year 1665, Sir Isaac Newton discovered by his experiments with glass prism that white light, when passed through a prism, split into 7 colors. The band of these 7 colors formed on the screen is known as spectrum of light. The 7 colors of the spectrum are violet, indigo, blue, green, yellow, orange, and red. The phenomenon of splitting up of white light into 7 colors on passing through a transparent medium is known as dispersion of light. White light is a mixture of 7 colors. The effect of a glass prism is to separate the 7 colors of the white light. The acronym VIBGYOR will help you to remember the sequence of the colors. Why do light get dispersed when it passes through a glass prism? This is because different colors of white light travel at different speed through a glass prism. In air, these colors travel at the same speed, hence we do not see them as separate colors in atmosphere. The amount of deviation or refraction depends on the speed of the colored light in glass. Since different colors travel at different speeds, they are refracted by different angles. Hence, they give out a spectrum of 7 colors. Let's understand that red color has the maximum speed inside the glass prism. So, red color is least deviated and it is the first color that comes out of the prism. Due to this, red color forms the upper part of the spectrum. On the other hand, violet color has the minimum speed in glass prism, so violet color is deviated the maximum. Due to this, violet color appears at the bottom of the spectrum. You may think that refraction happens in a glass slab also. But then, why don't we see the spectrum when light passes through a glass slab? This is because glass slabs have parallel surfaces. So, the light rays slow down inside the glass slab in the same rate and speed up when it comes out from the glass slab also at the same rate. But in a prism, since the surfaces are not parallel to each other, the light rays emerging from the prism finally makes a spectrum. As discussed, Sir Isaac Newton was the first who demonstrated that white light is a mixture of lights of 7 colors and the prism splits these colored beams. Newton tried to split the colors of the spectrum of white light further by using another similar prism, but he couldn't get any more colors. Later, when he kept the prism in an inverted position in front of the dispersed light, he observed that the 7 colored lights of the spectrum can be recombined to give back white light. This proved that white sunlight is made up of 7 colors and a glass prism merely separates these 7 colors. One of the most beautiful examples of spectrum formed by dispersion of sunlight is provided by nature in the form of a rainbow. The rainbow is an arch of 7 colors visible in the sky. This is produced by dispersion of sun's light by raindrops in the atmosphere. In the next video, we'll discuss in detail how a rainbow is formed and what are the different phenomena that take place when sunlight enters into a water droplet. Hope you all are clear with dispersion of light. Thank you for watching the video. If you like the video, subscribe the channel. Go through the channel for more contents of class 8, 9, 10 science.